Hey everyone, and welcome to another day of Algebra 2, where we will be going over the quadratic formula, which is something I know that you all have done in Algebra 1 and Geometry. So why don't you take 30 seconds and pause this video and see if you can remember the quadratic formula before I write it. Cool, so hopefully some of you wrote it and see if you can compare to the quadratic formula that I'm going to write. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Notice how the square root goes over this whole entire section, so nothing should be out of the square root, and the 2a does not go over the x, only this part of the function. So leave it, this is exactly what it should look like. Hopefully you did great and you got it right, otherwise please fix it if you did not. Cool, now we're gonna make a spot for our thinking question. We're gonna do a think aloud today. And as always, we're gonna have a thinking question. And we're gonna do our first example. Okay, example 1. Determine the roots. Determine the roots of negative 2x squared equals 6x plus 12. And as always, make sure we have a space for our evaluation steps. And we are going to begin our think aloud. And remember, you are responsible for two things. You are responsible for writing down all my notes and getting my thinking question. Once again, if you cannot get the thinking question, you just really don't know what it is, text a friend and get it from them, because you will be responsible tomorrow to tell me the thinking question. Great, and let's begin. Determine the roots of negative 2x squared equals 6x plus 12. We need to determine the roots. And I know that roots are the x-intercepts, so the y value is going to have to equal 0, because I know all x-intercepts have a y value of 0. So how can I use the structure of this equation in order to determine the roots? How can I use the structure of this equation in order to determine my roots? Well, first I can see here that this equation is not set up in standard form, so I really can't do anything yet because it has to equal 0 in order for me to be able to find those roots, because the y has to equal 0. The first thing I want to do is set my equation equal to 0. Equal to 0. Great, so in order to do that, I need to use inverse operations. So I'm going to want to move this negative 2x squared to the other side of my equal sign. And I want to specifically move this because I want to make my a value positive, because right now it's negative. So if I move it over, it'll become positive. I'm going to add 2x squared to both sides. So negative 2x squared plus 2x squared will be 0. So I'm 0 equals 2x squared plus 6x plus 12. Great. Now my equation is in standard form, so I'm really familiar with this form, right? And I know that the y-intercept is 12, and this is my a value, it tells me it opens up, but I'm not asked for those things, I'm asked for the roots. So how can I use the structure of this equation to find my roots? Well, I know when we did factoring, I could factor to find roots. And I remember that my first step of factoring was to find a GCF. So I'm going to do that here too. Since I'm looking for roots, I'm going to take out a GCF. So between 2x squared, 6x, and 12, the GCF is 2. So I'm going to pull a 2 out from this equation. So I'm going to be left with x squared plus 3x plus 6. Okay, cool. Equals 0. Great. So now looking at that, I'm going to determine what my a, b, and c values are. A is equal to, and I'm going to look inside. These are my new values, because these are equivalent. I can use these a, b, and c values. So a is 1, b is 3, and c is 6. So because a is 1, I'm going to try to use reverse FOIL to factor this. So I'm going to look for two numbers that multiply to 6 and add to 3. 6 and 1, 2 and 3, that gives me 7 and 5. So it looks like based on the structure of this equation, I can't actually factor this, so it's not factorable. So I know that my roots are not going to be rational. So because it's not factorable, I can still have roots, I just know they're not going to be rational roots. So how can I use the structure of this equation to find my roots? Well, I remember from Algebra 1, I had this cool thing called the quadratic formula. So for my next step, I'm going to use the quadratic formula, and I'm going to substitute my a, b, and c value into that formula. So I'm going to do the quadratic formula. So that's going to look like x equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. And I'm going to substitute my values into this equation. So, and I'm going to use these a, b, and c values here, my small ones, because these will make it much easier for me to simplify later. So I'm going to do x equals. It's always x equals because that's what I'm solving for. I'm solving for the roots, which is what is x. So x equals the opposite of b. So what's the opposite of 3? Well, that's negative 3. Plus or minus, because I'm going to do both. The square root of 3 squared minus 4 times 1 times 6 over 2 times 1. So now I have x equals, and I'm going to use gem dots to simplify it. Sorry, I meant to write substitute into quadratic formula. So step 5 is gem dots. So I'm going to simplify. So to simplify this, I know I'm going to do the grouping. So I know that a radical is a grouping, so I'm going to use that first. So I have the opposite, negative 3 plus and minus the square root of. I'm going to do all this under the radical. So 3 squared I know is 9. Negative 4 times 1 times 6. Negative 4 times 1 is negative 4. Negative 4 times 6 is negative 24. Over, and then 2 times 1 is 2. Great. Now I'm going to combine these. So I have x equals negative 3 plus minus the square root of negative 15 over 2. I see that I have the square root of negative 15. I learned that I can't take the square root of a negative number. So how can I use the structure of this equation in order to simplify this so I don't have a negative under my radical? Well, I remember that if I have a negative under my radical, I can actually rewrite this square root of negative 15 as the square root of negative 1 times the square root of 15. Because if I have the same radical and I'm multiplying, I can actually multiply them out. So I know these are equivalent. And I remember that the square root of negative 1, oh my god, can be written as I. It's my imaginary number. So I know that this can actually be rewritten as I times the square root of 15, or I square root of 15. Which is so cool. So I know that I have the imaginary number here because I had a negative under my radical. So that's telling me now that I know, because I have a negative under my radical, that my roots are going to be imaginary. So this is not actually going to touch the x-axis, but it still has roots that I need to identify. So I'm just going to simplify this further and say x equals, and I have negative 3 plus and minus this I square root of 15 over 2. Now I just want to make sure this is simplified completely. So I look at the coefficients, negative 3 and 1. Can I divide both of those by 2? I can't. So that means this is simplified completely. So I know that these are my roots. I have 2 roots. So there are 2 imaginary roots. And once again, I know they're imaginary because I had a negative under my radical, and I have the imaginary number in my answer. And I know there are 2 because I have negative 3 plus I square root of 15 over 2, and negative 3 minus I times the square root of 15 over 2. So this is telling me there's 2 roots that are imaginary. So I've found my roots. And I'm not going to graph those because they don't hit the x-axis. And we've determined our roots. Great, so come to class tomorrow with questions if you have any. You can rewatch this video and pause in places and ask questions. You can also email or text me if you want to have anything cleared up for you. Otherwise, be prepared for class tomorrow. Thanks.